Right, so I've had a request to go through question 9 of the exercise 11e, looking at substitutions. The difficulty here, I think, is that this asks you to find a suitable substitution, but it at least gives you the clue that we're looking for something using trig. So I am going to suggest we use x equals sine theta as a suitable substitution. Let's go ahead and differentiate. So we get dx d theta is equal to cos theta. So now rearranging, we can get dx equals cos theta d theta. Lovely. We can substitute that back in at any point. Let's move on and do the next step, which is finding the limits. If x is equal to root 3 over 2, then theta is equal to sine of root 3 over 2, which is pi by 3, always working in radians. If x is a half, then theta is equal to inverse sine of a half, which gives us pi by 6, working in radians. Just give that one of them. Okay, so we've got those upper and lower limits for the integration. Next, we should look at trying to do the substitution, get all the bits substituted in. So I'm going to rewrite the integral, which is x squared times the square root of 1 minus x squared dx. At every step, I'm going to replace the x with sine theta, which will give me x equals the integral of sine theta times by sine squared theta, times by 1 minus sine squared theta square rooted dx. Now I will replace the dx with cos theta d theta. So I get sine squared theta times 1 minus sine squared theta times cos theta d theta. That's had the effect of replacing every x with a theta. Now to simplify this, first off, I can recognise that 1 minus sine theta is equal to, 1 minus sine squared theta is equal to cos squared theta. So sine squared theta times by the square root of cos squared theta times cos theta d theta. That's obviously going to simplify to sine squared theta times by cos theta, the square root of cos squared is cos, times by cos theta d theta, which, I can go one more step, gives me sine squared theta times cos squared theta d theta. And as you'll notice, I haven't put the limits in. I can write them in now. It's going to be between pi by 3 and pi by 6. The next phase of this is to change from sine squared and cos squared, things that we can't integrate directly, into something that we can integrate directly. I'm going to use the double angle theorem here. Sine 2 theta is 2 cos theta sine theta, or sine theta cos theta. So if I have cos theta, so half sine 2 theta is sine theta cos theta. Just makes more sense writing it that way around. And if I square it, a half sine 2 theta all squared will equal sine theta cos theta all squared, which is sine squared theta cos squared theta, which is what we've got. So this is equal to the integral between pi by 3 and pi by 6 of a half sine 2 theta all squared d theta. which I can rewrite as a quarter sine squared 2 theta. Again, we can't directly differentiate sine squared, so we're going to use the cos 2 theta substitution this time. Cos 2 theta is equal to 1 minus 2 sine squared theta. Going ahead and changing that, I'm going to get cos 4 theta is equal to 1 minus 2 sine squared 2 theta. That's now looking a bit like the thing that I've got, sine squared 2 theta. So sine squared 2 theta is equal to a half of 1 minus cos 4 theta is equal to sine squared 2 theta. So I can substitute this back in to my equation, so my expression that I'm trying to differentiate. So I get I equals the integral between pi by 3 and pi by 6 of 1/8 of 1 minus cos 4 theta, and that is something that we can work with. So if I integrate now, I get I equals square brackets because we've done the integrating, 1/8 of theta minus a quarter sine 4 theta using the standard patterns, and that is between, well, I'm just going to change the brackets, that's between pi by 3 and pi by 6. Do the substitution and we get I equals 1/8 of theta minus a quarter sine 4 theta, so 4 pi by 3. That gives me minus root 3 over 2, but then times by quarter, guess. So we get minus plus root 3 over 8. Okay, and then minus, substitute in the pi by 6, we get 1/8 of pi by 6 minus, this time, root 3 over 8 again. That, adding all of that up together, I'm going to get 1/8 of, let's do pi by 3 minus pi by 6. That gives me pi by 6. And then adding root 3 over 8 minus root 3 over 8 gets me root 3 over 4. And I'm happy with that as an answer. If you like to expand it, I guess you could. You get 2 pi plus 3 root 3 over 96, which is the answer given in the back of the book. Come back to me if there's any issues.